Hey everyone, and welcome. Today, we're going to cut right through all the noise surrounding AI. We're going to demystify the real difference between the kind of AI we've been using for years and these powerful new generative models that feel like they've just changed everything overnight.
It feels like AI is suddenly everywhere, right? But the truth is, it's been in our lives for a long time. It's been powering everything from your Netflix recommendations to your bank's fraud detection. So the real question, the one we're here to answer is, what makes today's AI so fundamentally different? Let's dive in.
Okay, to really get that, we need to look at this fundamental divide. You can think of it as old AI versus new AI. Or to be a bit more precise, we're talking about traditional machine learning versus large language models.
So this slide right here, it basically lays out the core DNA of each one. On one hand, you've got LLMs, which are built from the ground up to understand and generate human language. Text, conversation, all that messy stuff. Then you've got traditional ML, which is all about predicting things from neat, orderly data like you'd find in a spreadsheet. The best way to think about it is this. An LLM is a total generalist, a real jack of all trades. One single model can be a chatbot, a summarizer, and a translator. But a traditional ML model, that's a specialist. You need one specific model for fraud detection and a completely different one for sales forecast.
So when you boil it all down, it really comes back to one thing: the data. Traditional ML is the king of structured data. We're talking spreadsheets, databases, numbers, and columns. It loves that stuff. But LLMs? They live in the messy, unstructured world of human communication. Text, articles, conversations, all the nuance and context that comes with how we actually talk.
Okay, so how in the world does an LLM actually understand language? Well, it all comes down to this revolutionary architecture called the transformer. So let's pop the hood and see how these models actually think.
It basically happens in 3 key steps. First up, there's tokenization. The model takes a sentence and just breaks it down into these reusable little pieces, kind of like Lego blocks, super efficient. Then, and this is the real magic ingredient, comes attention. This is the part where the model connects the dots, figuring out which words relate to which other words in the sentence. And finally, you have the feed-forward network. You can think of this as the model's giant brain or knowledge base. It uses everything it learned from trillions of words to add deep meaning to the relationships it just found.
Here's a great way to understand how that attention mechanism works. Take a sentence like, "The animal didn't cross the street because it was too tired." The word "it" is basically asking a question. Hey, who or what is it? And all the other words in the sentence offer up clues. The word animal basically raises its hand and says, me, while the word street is just kind of there as the location. The model weighs all these signals to figure out correctly that it refers to the animal. Pretty cool, right? Now, this core transformer architecture isn't a one-size-fits-all thing. It actually comes in 3 main flavors. You've got encoder-only models, like BERT. These guys look at the whole sentence all at once, which makes them amazing at understanding context. Then you have decoder-only models, like the GPT family you've probably heard of. They process text one word at a time, which is perfect for generating new text. And finally, you have encoder-decoder models that, you guessed it, use both. They're ideal for something like translation, where you have to fully understand the input before you can create an output. It just goes to show you need the right tool for the job, even inside the world of LLMs.
All right, so we've got the blueprint, the architecture, but how do you go from that, a blank slate, to a powerful AI that can actually hold a conversation? Well, let's zoom out a bit and look at the absolutely monumental effort that goes into building and training one of these things.
The pace of progress here has been absolutely breathtaking. Seriously, in just 5 years, we went from BERT, which completely revolutionized how models understand text, to GPT-4, a massive multimodal model that can process images just as easily as text. Just look at this timeline. It has been a total explosion in both scale and capability.
And that progress, it comes from a really sophisticated, multi-staged assembly line, so to speak. It all starts with pre-training. This is where the model just reads the internet, basically. It learns the patterns of language by predicting the next word over and over across trillions of words. Next, it gets refined through instruction tuning. This is where it learns how to actually follow your commands. And then comes the final and maybe most crucial step, alignment. This is where humans get involved. They provide feedback, ranking the model's answers to teach it to be helpful, honest, and harmless. It's a whole process called reinforcement learning from human feedback, or RLHF for short.
But even after all of that incredible training, the model isn't perfect. Far from it. And this is key.
getting the best results isn't just about having the biggest, most powerful model. It's also about knowing how to talk to it.
And that brings us to one of the biggest challenges with LLMs, something you've probably heard about. They can hallucinate. I mean, they can just make stuff up and state it with complete confidence, even when it's totally false. So the big question is, how do we ground them in reality? How do we make them more reliable and truthful?
Well, a huge part of the answer lies in how we ask the questions, in our prompting. For example, just asking the model to think step by step can dramatically improve its reasoning. But a really powerful technique, a real game changer, is something called Retrieval Augmented Generation, or RAG. This is amazing. It lets you give the model a specific set of documents, say your company's internal knowledge base, and tell it to only use that information to answer. It's like giving the model an open book test, which is a fantastic way to stop it from making things up. And there are other cool tricks too, like telling it to act as an expert, which can really boost the quality of the answers.
So, how do we tie all of this together? Look, the key takeaway here isn't about which type of AI is better. That's the wrong question. It's about realizing that LLMs and traditional ML are just different tools in the toolbox, and each one is perfect for a different kind of job.
And this slide gives you a really simple guide for that. If you need something that works with language, a chatbot, a content writer, a tool to summarize long documents, an LLM is absolutely your go-to. But if you're trying to detect credit card fraud or forecast next quarter's sales or figure out which customers might leave, well, traditional ML, working with that nice structured data, is still the most efficient and effective tool you can use.
So what this really means is that the future isn't about one replacing the other. It's all about synergy. Just imagine this for a second. A traditional ML model flags a transaction as potentially fraudulent. Then, an LLM instantly kicks in and generates a clear, easy-to-read report for a human analyst explaining exactly why it was flagged. Now that's the real power of using these two systems together.
And that kind of leaves us with one last big thought to chew on. As both of these incredibly powerful forms of AI continue to get better and better, what new doors are going to open? What problems that seem impossible today might suddenly become solvable when we combine the raw predictive power of machine learning with the deep contextual understanding of language that LLMs have? The possibilities, well, they're really just starting to unfold.